All right, let's apply what we've learned about graphing trig functions to a cotangent function. So in this case, I want to graph two cycles of y equals 3 times the cotangent of 4 times the quantity x plus 2 pi over 5. Now, just as far as notation goes, understand that this 4 times x plus 2 pi over 5 is all the argument to the cotangent function. And in fact, you may want to rewrite it, maybe not, it doesn't matter really, but you may want to rewrite it as 4x plus 8 pi over 5, because you could distribute the 4 here, and then you don't have parentheses within brackets. So that's the approach that I will take. And the first thing we need to address is the shape of the parent cotangent function. So the parent, the y equals cotangent of x function, from 0 to pi, So tangent and cotangent are different from the other functions because a cycle only requires a rotation from 0 to pi of whatever your argument is. So when I look at my cotangent function from 0 to pi, it starts with an asymptote. It ends with an asymptote. In the middle, it's 0. And in the first quarter, it's positive 1. And in the third quarter, it's negative 1. And so it does this kind of thing. Comes across here and then curves down to the asymptote, curves up to that asymptote. So that's one cycle of the cotangent function. Then what I need to do is my y transformations. In this case, I only have one y transformation, and it's multiplied by 3. So I'm going to multiply my y values by 3. So now my middle is still 0 because 3 times 0 is 0, but 3 times 1 is 3, and 3 times negative 1 is negative 3. Now, I could certainly stretch this out to where 3 is up here higher than my 1 was over here. That's really what's happening. But rather than make my graph more difficult to draw, I'm just going to change my scale so that now this is 3 and this is negative 3. Okay? And then my cycle still begins and ends with an asymptote. In the middle is 0, the first quarter is 3, and the third quarter is negative 3. And make sure you draw this as a curve, not as a straight line. So it looks something like that now with my y values adjusted for my y transformation. Okay. Then I need to deal with all my stuff inside, all my x transformations. So I need this shape that I've got drawn here, but I need to know where this cycle starts and where it ends. Okay. So it starts, for a cotangent or a tangent, it starts whenever the argument, whenever that whole thing, sorry for my handwriting there, when that whole argument equals 0, and we'll leave some space to solve that, and it ends when that argument equals pi. I can't emphasize enough, it's pi and not 2 pi here, like sine, cosine, secant, cosecant, okay? So don't forget that. All right, so now I'm going to solve the first equation for x, so I will subtract 8 pi over 5 and divide by 4, which gives me negative 2 pi over 5. Now, if you're wondering how to do that so fast, dividing by 4 is the same thing as multiplying both sides by a fourth. And then the 4 and the 8 reduce to a 2 on top, okay? So I now know that this x value here is going to be negative 2 pi over 5 when I go to graph my function. Okay, let's find out what my ending x value is by solving my second equation. So I've got 4x. I need to subtract 8 pi over 5 from pi, which is the same thing as 5 pi over 5. Same thing as 5 pi over 5. Okay, so I need to subtract 8 pi over 5. That leaves me negative 3 pi over 5. If I multiply by a fourth, that's negative 3 pi over 20. So when I'm looking at my x values here, I need to choose a scale when I go to set up my graph. So since pi over 20s are smaller than pi over 5s, I'm gonna go with pi over 20s. And so this guy, if I multiply the top and the bottom by 4, so times 4 over 4, that's going to give me negative 8 pi over 20. Okay? So I'm going to start at negative 8 pi over 20 and end at negative 3 pi over 20, and I'm going to draw this shape between those x values. So I need to set up my x-axis. I'm going from negative 8 pi over 20 to negative 3 pi over 20. So I need lots of room on the left side of my y-axis. So let's say this is my y-axis. And I'm going to go in pi over 20s. So this will be negative 1 pi over 20, negative 2. Here's negative 3 pi over 20. That's my end point. Negative 4, 5, 6, 7, 8. So negative 8 pi over 20 is there. So I'm going to be graphing between negative 8 pi over 20 and negative 3 pi over 20. I need to graph my cotangent function that I've got drawn right here. Now my y values that I care about are negative 3, 0, and 3. So now, sorry, I forgot to draw my x-axis. My y values are negative 3, 0, and 3, and I'm going to kind of squeeze those closer to the x-axis. That's a hint for you when you're graphing tangent and cotangent to get your significant y values close together. Then your curve will look more like a curve than a straight line. So you might play around with that. For example, if I put my 3 and negative 3 really up high and down low, when I go to graph that, it's going to be really hard to make it look like a curve. All right, so the pattern for cotangent is it starts the cycle with an asymptote, which means it ends the cycle the same way with an asymptote. In the middle, it's at 0. So where is the middle? Well, the middle consists of, the whole cycle consists of 1, 2, 3, 4, 5 intervals. So I need to go in 2.5 intervals, which is right there, to get my midpoint. Okay, so I know that's going to be 0 at that halfway point. Now, the quarters, since the middle is 1, 2.5, the first quarter is going to be 1 1/4, like right there. That's the halfway point of the first half. And I know right there, my cotangent function has to be 3. And then over here, my third quarter, which is, again, halfway between the middle point and the end, it's got to be negative 3. So it's got to be somewhere like that. And then I can draw in, on the left, it's going to curve and then come up and approach this asymptote. And on the right, it's going to curve and go down and approach that asymptote. Okay? So again, in the middle, it's 0. The left was positive 3. The right was negative 3 with asymptotes on the ends. All right, so that's one cycle. In fact, we could go ahead and identify the period of this function simply by counting each tick mark here is pi over 20, right? Each tick mark is 1 pi over 20. So that means I've got 1, 2, 3, 4, 5 pi over 20s to make up a cycle. So 5 pi over 20, or you could reduce that to pi over 4. So this function has a period of pi over 4. Now I need to graph 2 cycles, so I need to make a copy of this cycle and attach it to the right side or the left side of what I have. And since I've got room on the right side, that's what I'm going to do. So I need to measure out another 5 pi over 20s to get my next cycle. So 1, 2, 3, 4, 5. My second cycle is going to end right here. And it's easy to know this x value because it's 2 grid marks, and each grid mark is 1 pi over 20. So this is 2 pi over 20. Now I just apply the symmetry of this curve. On the beginning of a cotangent, I've got an asymptote. Well, I've already got my asymptote at negative 3 pi over 20. That's the beginning of my second cycle. The end has to also be an asymptote because it's a cycle. It begins and ends the same way. The middle, which is 2.5 intervals in, is 0. And then the quarters, right here and right here, are 3 and -3. And so now I just repeat the curve, going up as I move left and going down as I move right. Now I'm just jumping over that -3 so we can see that and the graph doesn't become too jumbled. But it's not actually a break in the graph. So there are 2 cycles of this transformed cotangent function.